To all my students, good morning. How are you? How you have celebrated Dasara? Nice? Okay. Today in this video, addition theorem of probability. Addition theorem of probability I have explained very detailedly. Please go through this video. In my book, I have explained some questions. I answered some important questions and go through them. And I have given you in my book some important properties of sets. Sets are very important in this chapter. For probability, sets are very important. Many times I told, sets are very important in probability. That is why I have explained about sets. In this video. Please go through this. Okay. Next. Here, sets operations and sets properties I have explained very clearly. Before knowing addition theorem of probability, in this video only addition theorem in this video. In this video, the addition theorem of probability needs sets. I have given Venn diagram, John Venn diagrams. With John Venn diagrams, I have given it. British logician John Venn explained sets in the form of diagrams that I explained very clearly in my book. Please go through it. For A union B, in the sets you have to learn. First of all, X belongs to A union B implies X belongs to A, or X belongs to B, or X belongs to A and B. X does not belong to A union B implies X does not belong to A and X does not belong to B. These things are explained by showing Venn diagrams. And another point also I told by Venn diagram, A union B in the set form equals to A plus B minus A intersection B. So in the form of probability, so if you tell in number, N of A union B equals to N of A plus N of B minus N of A intersection B. How it is? It is shown in Venn diagram also. Please observe it. And I have explained about P of A dash equals to 1 minus P of A. It is in the set theory, you have learned it. A intersection A dash equals to phi. Therefore, P of A intersection A dash equals to P of A intersection A dash equals to P of phi. P of phi equals how much? 0. Here, 1 equals to P of S. We can write P of S equal to 1. P of S, we can write this as P of A union A dash. A union A dash can be written as P of A plus P of A dash. Okay. So P of A dash can be written as 1 minus P of A. This is also very important. And some other sets, properties also I have given you. I have explained it. Please go through it. And some inequality is important. The inequality in the sets, that is, you see here, A intersection B is always less than A, set A. It is less than or equal to A union B. It's natural. And less than or equal to A union B. So again I'm telling, in the set theory, A intersection B less than A union B. With the same help we have taken, and for any two events A and B, P of A intersection B less than or equal to P of A less than or equal to P of A union B. That also I explained it. And I have answered some questions. I have which type of questions, very important questions I have discussed and answered it. And now another from the set theory, you have to remember A bar intersection B bar equals to A union B whole bar. A union B whole bar equals to A union B whole bar equals to A bar intersection B bar. If we just apply P of A bar intersection B bar equals to P of A union B whole bar, we can tell like that. If you know set result or set theory result, some properties of set theory, if you know, just if you add n's both sides and p's both sides, you will get probability of them. So anyhow, you have to learn, you have to remember some set theory relations, some set theory properties. You must learn and you must remember. With the help of that, you can do some questions of probability very, very easily. And in one question, GP infinity series, you know very well GP infinity series, 1 plus x square plus x cube, so on up to infinity. GP infinity series. So what is that? A by 1 minus r. S infinity equals to A by 1 minus r. So 1 by 1 minus x. In the series now I have given 1 plus x square plus x cube, so on up to infinity. So that GP series, sometimes AGP series, sometimes AP series, sometimes infinite series in algebra, from algebra, these will be applicable, these will be helpful, or this concept is in the topic of probability. We apply this algebra formula also in probability doing questions we use. So once I told probability, it is what not, it is in connection with all branches of mathematics. All branches of mathematics. Later I will explain in geometry, I will explain in calculus with integration and limits, and I will explain in in algebra. Once I gave you in connection with the matrix, one question I discussed. Okay, in matrix algebra, in vector algebra, in complex numbers also, I will give you model wise one question from different branches of mathematics. I will discuss. These type of questions will be appearing more often. These type of questions will be appearing in the competitive exams. Not only JEE, IIT, not that. Even in regional engineering examinations will be there. In India, so many engineering and deemed universities examinations also will be there. For that also this will be useful. Okay. Apart from all this, you have to remember to subscribe and to click the bell icon. Subscribe, share, subscribe, like, share, subscribe, to click bell icon. You will get more updates and you will be in touch with my videos and you will learn more things. Okay, please now, without wasting time, go through my notes. Again, I am telling, subscribe my videos and tell all of your friends and kith and kinfolk and relative folk, to all, please tell, pass on this news and update my videos by clicking bell icon and subscribe it. Okay, thank you. Thank you very much. Hello, my dear students. Today we are going to learn addition theorem of probability. So before going to learn, we have to remember set theory, because set theory is playing important role in probability. British logician John Venn, he helped in mathematics and very popularly known as Venn diagrams. That is on his name only, John Venn, British logician. Please see here, I have shown you. Before going to learn addition theorem of probability, we have to understand additions of sets, union of sets, intersection of sets, difference of sets, subset of sets, phi set. All these sets of fundamentals of sets the student must know. First you see A union B. When A is subset of B, when A is subset of B, you see the figure, this is S, this is sample space or universal set. This is universal set. A subset of B, A union B, John Venn diagram will be like this. See, A union B can be expressed in diagram, in John Venn diagram, like this also. Not only like this, but also like this also. A union B when neither A subset of B, it is not A subset of B, it is not B subset of A, it is not A intersection B is, you see, A intersection B is not equal to phi, A intersection B is not null set, and B is not subset of A is not subset of B. In this case, the John Venn diagram will be like this. This is A union B, like this. This is A union B. In third way also, we can explain A union B. A union B when A and B disjoint. When A and B disjoint, the John Venn diagram will be like this. Separately A and B, and this is also A union B. This is also A union B. In three ways we can explain A union B. Here, firstly I told X belongs to A union B implies X belongs to A or X belongs to B or X belongs to A and B. Everybody must know this, the sense of A union B. X belongs to A union B implies X belongs to A or X belongs to B or X belongs to A and B. X does not belong to A union B implies X does not belong to A and X does not belong to B. From the set theory, please observe, from the set theory, N of A union B equals to N of A plus N of B minus N of A intersection B. You see here, naturally in the set C, A union B equals to A plus B minus A intersection B. It is very natural. So I apply N of A union B equals N of A plus N of B minus N of A intersection B, dividing both sides by N of S. So N of A union B by N of S equals to N of A by N of S plus N of B by N of S minus N of A intersection B by N of S. N of A union B by N of S is nothing but P of A union B equals to P of A plus P of B minus P of A intersection B. This rule you already learned in previous videos. So finally we got addition theorem of probabilities. P of A union B equals to P of A plus P of B minus P of A intersection B. In case A and B mutually exclusive events, then A intersection B equals to phi. In previous videos you learned mutually exclusive events. A and B, two sets mutual exclusive events, then A intersection B equals to phi null set, hence P of A intersection B equal to 0. Then this P of A intersection B will become 0. Then this and this will be remaining. P of A plus P of B equals to P of A union B. Only when A and B mutual exclusive events. Similarly, for three events, P of A union B union C equals to P of A plus P of B plus P of C minus P of A intersection B minus P of B intersection C minus P of A intersection C plus P of A intersection B intersection C. Please see this once. P of A union B union C equals to P of A plus P of B plus P of C. When A, B and C are mutually exclusive. That's all. If they are not mutually exclusive, P of A plus P of B plus P of C minus P of A intersection B minus P of B intersection C minus P of A intersection C plus P of A intersection B intersection C. certain properties. 1 equals to P of S. Everybody knows probability of sample space. Sample space. Probability of sample space. A union A. What is this? Dash. A union A dash. A union A dash equals to P of A plus P of A dash because A intersection A dash equal to 5. Because A and A dash are mutually exclusive. A and A dash are mutually exclusive. A is one part, one set. A dash is another set. Totally, if we add them, A union A dash equal to sample space. Yes, S equals to A union A dash. So P of S equals to P of A union A dash. P of S means probability of sample space is always 1, the maximum value of probability. Union plus, because A and A dash are mutually exclusive. Implies P of A dash equals to 1 minus P of A. This is very important. You have to remember. Next, if A and B are any two sets, A minus B, these are the set properties. I think you have been already aware of sets relations and their proper set relations and set theory properties. With those properties only, this probability will be depending on. Now, A minus B intersection, A intersection B. A intersection B is different. A minus B is different. Both intersection, nothing will be there. That is null set. And also, A equals to, we can tell, A minus B union A intersection B. A equals to A minus B union A intersection B. This also you have learned in 9th class, 8th, 9th, 10th, and intermediate also, and 11th class, 10th class, 9th class, set theory. By Venn diagrams we can tell. Also A equals to A intersection B dash union A intersection B. Since A minus B equals to A intersection B dash, these are very important. That is why I have given in this. These are very important cases. We have to remember. First one, certain properties. First one, P of A dash equal to 1 minus P of A. And A intersection A dash is 5. And the second one is, I have told you already, like this. And some applications now. Applications. This is the use and utilization of addition theorem of probability. Use and utilization of addition theorem of probability. I have given some applications or illustrations. Parallel to this, you have to do NCERT 12th class NCERT textbook you have to open. You have to go to the topic of probability and you have to do the sums in the exercise. These sums in this video, for the model sake, various model questions, of course, which have been in previous competitive exams, might have been. Even then, these questions are not sufficient for your practice. You have to continue parallel to this video from NCERT textbook. You have to do the exercise in the topic of probability, 12th class NCERT textbook you have to refer. Now see, A and B are two events where P of A equal to 0.25 and P of B 0.5. So P of A is given 0.25, P of B is given 0.5. The probability of both happening together means P of A union B. The probability of both happening together means P of what is that? P of A union both happening together means 0.14. Then the probability of both A and B not happening. First of all, the probability of both A and B not happening. Probability of both A and B not happening means probability of both A and B not happening means A bar intersection B bar. P of A bar intersection B bar equals to P of A union B whole bar. This is set theory principle, set theory rule, set theory property. Exactly we can say set theory property. What is the property? A bar intersection B bar equals to A union B whole bar. Remember this. With regard to the important models and important property applications only, I am discussing. A bar intersection B bar equals to A union B whole bar. Applied both sides P. Apply both sides P. P of A bar intersection B bar equals to P of A union B whole bar. A union B whole bar is 1 minus P of A union B. 1 minus P of A union B is, you know very well, just your land addition theorem, P of A plus P of B minus P of A intersection B. You know very well. That is what? P of A 0.25, P of B 0.50, P of A intersection B. Here, the probability of both happening together. The probability of both happening together means intersection. Both happening together. Probability both happening together, intersection. Remember this terminology, this phrase, logical phrase, which gives the meaning intersection of A and B. So, intersection B, P of A intersection B 0.14. If you simplify it, 0.39. So, here, complete set theory property A bar intersection B bar equals to A union B whole bar. Another important point is probability of both happening together means intersection B. Come to the second question. various different models. The probability that at least, at least one of events A and B occurs. At least means A union B. At least means A union B. P of A union B. At least means one of events A and B occurs means P of A union B. Here you observe. Here both happening together means P of A intersection B 0.14. If A and B occur simultaneously with probability 1 by 5. What is 1 by 5? Here another terminology. A and B occur simultaneously. A and B occur simultaneously means what? P of A intersection B 1 by 5. At least means what? P of A union B 3 by 5. At least A union B. A and B occur simultaneously. A intersection B. Here, you see, both happening together. A intersection B. These type of terminology, these type of phrases used in probability questions, you must understand what is it. Now, you are given P of A union B 3 by 5, P of A intersection B 1 by 5. You are, I think, P of A union B formula, addition formula, P of A plus P of B minus P of A intersection B. P of A union B 3 by 5 equals to P of A plus P of B minus P of A intersection B is 1 by 5. Therefore, P of A plus P of B how much? 3 by 5 plus 1 by 5, 4 by 5. Now we want A bar, B bar. What is P of A? 1 minus P of A bar. What is P of B? 1 minus P of B bar. So P of A bar plus P of B bar equals to 2 minus 4 by 5, 6 by 5. This is P of A bar plus P of B bar. That is the requirement of us. What is the question? P of A bar plus P of B bar. How to find? You have to find like this. P of A plus P of B. And next you write like this. For this. And for this you write like this. You got like this. Observe. Third question, the probability that A speaks truth is 4 by 5. So P of A is 4 by 5. The probability that B speaks truth, P of B 3 by 4. So A speaks truth probability 4 by 5, B speaks truth probability 3 by 4. A speaks lie, P of A bar 1 minus 4 by 5, 1 by 5. P of B bar, B lies 1 minus 3 by 4, 1 by 4. So truth probability, lie probability, truth probability, lie probability of B, I have written. Now the question. The probability that they contradict each other when asked to speak on a fact. The probability that A speaks truth is 4 by 5, lie is 1 by 5. Probability that B speaks truth is 3 by 4, lie is 1 by 4. The probability that they contradict each other when asked to speak on a fact. So it means what? The probability that if A speaks truth, B doesn't speak, and if B speaks truth, A doesn't speak truth. If A speaks truth, B lies. If B speaks truth, A lies. That I have written like this. Requirement: P of A intersection B bar, P A intersection B bar. A speaks truth, B speaks lie. A speaks lie, B speaks truth. You have to write like this. You have to express like this. P of A intersection B bar plus P of A bar intersection B. This is called, in the question, they contradict each other when asked to speak on a fact, on truth. That is P of A, P of B bar, and P of A bar into P of B. P of A we know 4 by 5, P of B bar 1 by 4, P of A bar 1 by 5, P of B 3 by 4. These all already we have counted it, 7 by 20. On the probability 7 by 20, A and B contradict on saying one truth. You see, fourth model, this is a different one. A and B toss a coin alternately on the understanding that the first to obtain heads wins the toss. The probability that A wins the toss. A and B toss a coin alternately. A and B toss a coin alternately means what? A toss a coin. He gets a head or tail. We don't know. Afterwards, immediately after it, B toss a coin. He gets a head or tail. We don't know. So A and B toss a coin alternately. Okay. On understanding that the first to obtain heads. What is the understanding? That the first to obtain heads wins the toss. Who obtain heads, he is deemed as winning the toss. The probability that A wins the toss, for that. You see, for head probability is 1 by 2, tail probability is 1 by 2. Required probability I am writing here. P of A, observe, P of A means A toss, A gets head first, suppose. Then he wins toss. A wins the toss. This is one happening. Okay. Next. Second happening means this does not happen. Then what will be happening? This will not happen. What will be happening? A doesn't get head. He doesn't win toss. B doesn't get head. B doesn't get head. Again, to A it comes, tossing. So he gets head. A gets head. So now A wins the toss. Next. This is another way. This is another way. This is one way. First, A toss the coin. If he gets head, P of A is the first happening. The way of happening. In case it doesn't happen, the case may be like this. The case may be like this. A tosses, doesn't get head. B doesn't get head. Next. Again, A gets head. Next. This may be happening. This is the second case. Third case. A doesn't obtain head. B doesn't obtain head. Okay. A doesn't obtain head. B doesn't obtain head. Two trips. In the third trip, A gets or A obtains head. Like this case may be happening. So this is 1 by 2 probability, 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 1 by 2 whole to the power 5. This is 1 by 2 probability, 1 by 2 probability, 1 by 2 probability, whole cube. For A bar 1 by 2, for A 1 by 2. A means, here A means gets head. A bar means doesn't get head, toss. Doesn't get head. A gets tail. A gets tail, B gets tail, A gets head. This is one way. We are not sure this will be happening. First A doesn't get head, B doesn't get head. Okay, A doesn't get second trip. After tossing the second tossing, A doesn't get head, B doesn't get head. In the third tossing, A gets head. Like that. This is 5, 1, 2, 3, 4, 5. This is 1, 2, 3. This is 1. So this is 1 by 2. And this is 1 by 2 whole cube. This is 1 by 2 whole power 5 up to infinity. Here also, the application infinite GP series, infinite GP series, infinite GP series will be there. Infinite GP series will be there. S infinity equal to A by 1 minus R, that will be there. So by that calculation, 1 by 2 plus 1 by 2 whole cube plus 1 by 2 whole power 5 up to infinity. 1 by 2 by 1 minus 1 by 4, that is 2 by 3. Same question I will tell like this. Same one I can tell like this. GP series R less than 1, S infinity equals to A by 1 minus R. The algebra series formula, GP infinity series formula is applied in the probability. So in the probability, I have already said that all types of branches of mathematics are involved. Since P equal to 1 by 2, Q equal to 1 by 2. What is said? P equal to 1 by 2, P equal to 1 by 2, Q equal to 1 by 2. Means P means turns up head 1 by 2. Turns up tail 1 by 2. A gets head. P. This is head, this is tail. A gets head. P. This chance, this is one way. This way will not happen. Maybe like this will be happening. A doesn't obtain head. Q doesn't obtain head. B doesn't obtain head. A obtains head. A doesn't obtain head. B doesn't obtain head. A obtain head. This is another way. May happen. This is not happening. This is not happening. This is not happening. Maybe like this happening. A doesn't obtain head. B doesn't obtain head. A doesn't obtain head. B doesn't obtain head. A obtains head. Plus, like these happenings will be how many? Infinity. These are infinity happenings. What is P? Getting head 1 by 2. What is Q? Getting tail 1 by 2. P, Q square P plus Q power 4P plus so on. Of Q square means 1 by 2 square into 1 by 2 plus 1 by 2 whole power 4 into 1 by 2. Like this, it will be coming like this. 1 by 2, 1 by 2 whole cube, 1 by 2 whole power 5 up to infinity. 1 by 2 less than 1, no. What is the formula? S infinity equal to A by 1 minus R. So 1 by 2 by 1 minus 1 by 4 equals to 2 by 3. This model for A and B toss a coin alternately on the understanding that the first to obtain heads wins the toss. The probability that A wins the toss is 2 by 3.